Course 3, Lesson 45, we are looking at ratios involving totals. So taking what we know about ratios, and now we have a little bit more information, but missing some things. So we are going to use a 3-row ratio table to do this. One column showing the ratio that we have, one column telling us the actual count. So in this instance, we have the ratio of teachers to students is 3 to 22. If the total people in the assembly, so teachers and students, is 125 people, how many are teachers and how many are students? Well, we need to set up this 3-row ratio table with what we have. So let's plug that in. And so one row is going to tell me my students. One is going to tell me my teachers, both ratio and actual, and one is going to be my total. So that I can put in my ratio of 3 teachers to 22 students, and I could have switched those, it doesn't matter which row they go in, but it means that I have a total units of 25. 25 people are represented here, 3 being teachers, 22 being students. And then I also put in my actual count. My total number of people in this assembly is 125. So I want to know how many students, how many teachers are in there. Well, there's a couple ways to go about it. One is we can set up some proportions and say, maybe I want to find the teachers first. And I can set up saying 3 over 25 is equal to x over 125. And I can solve this with our normal proportion methods. I can use cross multiplication, I can simplify fractions, or I can see that there is a scale factor of times 5. So I'm going to do that on both sides. And I find that there are actually 15 teachers in the room. Well, I could set up another proportion for the students and say 22 over 25 is equal to y over 125, solve it. Or I can just realize that if I find the difference between the total and the number of teachers, I will find how many students, which means I have 110. So I can use a proportion to solve this. That's one way. Or I can use this ratio table to find a scale factor between my ratio and my actual count. And I can do that by saying from my ratio to my real, I multiply by 5. So I'm going to do that in each of these. And I do get my actual counts. So you can use proportions or you can use scale factors. 2 easy ways to find the answers. Let's try another. The ratio of cars to buses is 5 to 2. If there are 84 vehicles, how many cars and buses are there? So let's set up our ratio table by saying we have cars, we have buses, and we'll have the total ratio. And so we have cars is 5 to 2 buses. So we have a total of 7 vehicles on the road in our ratio. And then we have a total of 84 real vehicles, both cars and buses included. And so I can see a pretty easy scale factor here to say 7 times 12 is 84. So I'm going to do that all the way across. I'm going to multiply by 12 with all of these and see and make sure that this works out. So we get 60, and we get 24, which does add up to 84. So we have 60 cars, 24 buses for my total of 84. The ratio of cats to dogs is 2 to 3. If there are 85 pets in the Humane Society, how many cats and how many dogs are there? So I'm going to say we have cats to dogs to total. So I have 2 cats to 3 dogs for a total of 5 animals. And so there are 85 animals in total, 85 pets. So I could set up a proportion. I'll show you this way. Obviously, there is a scale factor as well. To say we have 3 over 5 is equal to x over 85. And I could, let's say I don't realize what the scale factor is and I cross multiply to say 5x is equal to 3 times 85, so that's 255. And so I divide by 5 and I get x is equal to, well, 255 is 51, I believe. And so we say I have 51 dogs. And it looks like 34 cats. And I could set up another proportion to make sure that is true, but as you can tell, the scale factor is actually 17 here. We could do that as well and get our answer. Okay, and let's just do 2 more examples. The ratio of pennies to nickels is 7:2. If there are 28 nickels in the jar, how many coins would there be altogether? So let's try this. We have pennies, we have nickels, and we have total. So pennies to nickels is 7:2 for a total of 9. And we have 28 nickels. Now, from what we've done before, it's really tempting to put 28 into the total box because that's what we've had before. But it says we have 28 nickels, not 28 coins overall. We have 28 nickels, so we need to put it into the actual count for nickels. And we see 2 times 14 is 28. So we're going to multiply by 14 for each of the other ones. And let's see. 14 times 9 gives us 126 total coins, which means that we, of course, have, let's see, 98 pennies. Okay? So make sure that you read the question before you go ahead and fill in your ratio table, just to make sure that you have the right information in the right places. And last example. The ratio of flowers to trees is 3:7. If we have 54 flowers, how many trees would there be? So we have trees to, I'll actually write this out. So trees to flowers to total. And so trees is 3, flowers is 7 for a total of 10. So if there are 54 flowers going in here, not total, 7 times what is 54? Well, as you can tell, there's not a great scale factor between those. So let's set up a proportion. And we can say 3:7 is equal to something over 54, since we want to know how many trees there would be. And so I would multiply out and get 7x is equal to 162, I believe, 3 times 54. And then we're going to divide by 7 on each side. Let's see. Let me just make sure. Oh, I see what I did. Sorry about that. I made a mistake of where I put my information. I actually didn't put the correct ratios in the right places. I should have had trees getting a ratio. Let's see, flowers getting a ratio of 3 and trees getting a ratio of 7, which will make this a whole lot easier, much nicer numbers, because we actually do have a scale factor. Okay, 54 divided by 3, well, our scale factor is 18. So we say 3 times 18 gives us 54, which means that I can do 7 times 18, 10 times 18, and we see we have a total of 180 plants, which means that I have 126 trees, which is 7 times 18. Well, I hope this is helpful for your homework and for studying.